All right, welcome everyone. Today we're going to be talking about angles, and I know you've talked about angles before, maybe not in depth. Angles is a very important concept in geometry. All right, you deal with angles a lot, just about the same as lines. All right, angles are just as important as lines because really, anytime lines intersect, they create angles. Okay, and lines intersect in almost everything. So we're going to discuss some angles today. So angle vocabulary, right? On the right, label the vertex and sides, okay? So when we talk about an angle, there's one point in the angle that is the vertex. And that is this angle, or this point right here, okay? This point is the vertex of the angle. It's the point that the two sides of the angle are meeting at. So let's go ahead and label those. So the sides are the two lines, or actually rays. Could be lines, could be rays, could be line segments, I guess. But they are the two sides that actually create the angle. And draw point P in the interior of the angle. So the interior of the angle is just anything in between the two lines, okay? And you know, these extend forever, right? So interior could still be out there as well. So there's point P, that's the interior, you know, inside. What is the name for the figure that makes an angle's side? So I kind of said this already. For this one, it's a ray. It also could be a line segment, I guess. Guess it can't really be a line because the angle stops at the vertex. So naming angles, all right? Angles are typically named with one or three letters, all right, with the vertex as the middle letter. There are three ways to name this angle. So one way to name the angle, if it's an easy angle, you could just say angle E, all right? That angle would be the vertex. The other way to name an angle, and so this first one doesn't always work, and I'll show you why in a second. The second one, all right, the second and third one are just two different ways to name the same angle. So when you're naming angles, all right, the vertex always has to be in the middle. So like, for example, we could say PET, all right? When you're naming the angles, you've got like a point, and then you've got a side to the vertex, and then you've got the second side, right? So we're going P to E to T. And these letters are kind of describing how the angle is made by its sides, like which points the sides go to. You could also go backwards, so you could also go from T, right, to the vertex. So the vertex is still in the middle, and then you could go up to P. So it actually literally does not matter. There's no difference, all right, between these two. So you could start with either, just got to make sure you go to the vertex second and then go out to the third point to describe that angle. If more than one angle has the same vertex, all right, these angles are called adjacent angles, all right? You might have heard the word adjacent in everyday, that's not the right letter, adjacent angles. You might have heard the word adjacent in everyday life, maybe on TV or something. It means next to, okay? So if you have two angles and they have the same vertex, right, and they share a side, that means they're adjacent. So there's two angles right here. We have this angle and we have this angle. They're right next to each other, all right? So they're adjacent. They share a side and they have the same vertex. So in this case, three letters must be used, all right? You can't just say angle E because which one are you talking about, right? So there's two angles here, all right? The first angle would be like FER, okay? The second angle would be like DER, okay? So there's only a one letter difference there, but that one letter is determining where you're starting, so it's changing which angle we are looking at. And you could name them different. This first one could have been REF, and the second one could have been RED. Okay, so just keep that in mind. Congruent angles, all right? Congruent angles are angles with the same, that was bad, M. Angles with the same measure, okay? All right, angles with the same measure. So we would say this angle right here, all right, is congruent to this angle, all right? And we can draw little lines there if we want. Let's say these are both 40 degrees, all right? So therefore those angles are congruent. It's kind of like how sides are congruent if they're the same length. Angles are congruent if they have the same measure, and we measure angles in degrees, okay? So there's 4 types of angles, all right? Draw an example of each of the following types of angles. So you should know this already, but in case you don't, acute angles, all right, are anything less than 90. Right angles are exactly 90 degrees. So this is less than 90. This equals 90, all right? Obtuse angles are greater than 90. Oh, that kind of looks, actually, there we go. Obtuse angles are greater than 90, but less than 180, okay? It can't be 180. And the reason for that is a straight angle equals 180. So a straight angle is like a line, right? It doesn't look like an angle, but you have to keep in mind that straight angles are also angles. So 2 more things. I know I'm kind of throwing a lot at you, but some of this should have been review, I hope. So similar to the segment addition postulate, all right, we also have our angle addition postulate, and it's literally the exact same thing. Okay? The parts make the whole. That is what this says. So if R is in the interior of QPS, all right, angle SPR, so that's the first angle, right? Angle SPR plus, let's change our color up here, plus angle QPR, all right? That's the second of our 2 half angles, okay? Those are equal to QPS, all right, which is the whole angle. So if we ignored the R and we went to the outside, I hope you can see these 3 angles here. So the 2 half angles add up to make the full angle. All right, and that's exactly, come on. That's exactly what the segment addition postulate was as well, all right? So finally, last thing, all right, an angle bisector, okay? So if you know how words work, right, you can kind of figure out what this means. Bi means 2, right? And sect means to cut. So think about like intersect, like cut it into each other, or like a section of something is like a piece that maybe you've cut out of it. So bi means 2, sect is to cut. So an angle bisector divides an angle into 2 adjacent angles that are congruent. So if we have our angle right here, okay, an angle bisector would go right through the middle of the angle and create 2 angles on both sides that are congruent. Okay, so that's important to know. So these might both be 30, for example. All right, so that would be an angle bisector. So that's all the notes for today, all right? You guys are gonna work on the practice problems, which are just on the second page, all right, and finish that up. If you have any questions, let me know, and have a great day.